Okay, welcome back to the second section of 11.6, Part 2, the area of irregular polygons. We're going to review some stuff really quick before we finish up this section. One thing I just want to recall your memory to would be the steps that we talked about the last time. I think these will be even more important for this time, so let's go over them real quick. My first suggestion would be to find your central angle, and remember you can do that by saying 360 divided by the number of sides of your polygon. After that, you're going to find half of your central angle that can create that right triangle that we kind of take out, so we can start solving for our apothem and the other sides of our right triangle. Step 3 would be to solve your right triangle, and before now we could just solve it by the Pythagorean theorem. Now we might have to use our trig functions, so sine, cosine, and tangent, to help us with that. 4, identify your side length. That way you can put that into your equation, along with your apothem. And then step 5, the last step, solve for that perimeter and then plug that perimeter and your apothem into your area equation. So using those steps, let's go down to example 3. A regular nonagon is inscribed in a circle with a radius of 5 units. Find the perimeter and area of the nonagon. Alright, well our first step, like we talked about before, was just finding that central angle. So we know that KLJ is going to be our central angle. So we need to find that by saying 360 divided by the number of sides, which you would say 9. So your central angle will be 40 degrees. So that KLJ is going to be 40 degrees. And we know that the apothem, LM, so that apothem, bisects the central angle. So I have created that KLM on the outside, so half of our central angle would be 20 degrees. So I would advise y'all to, pull out that right triangle with the apothem being one of your legs, just because it's going to be easier for you to see a little bit bigger and out of the way of all the other stuff in the picture. I just think that will be more helpful. So to find the lengths of the legs, use trig ratios to for our right triangle. So we know that LK is 5 because that is one of our radiuses that we can use. So now we have 20 degrees. We have our hypotenuse, but now we need to find the other two sides. So MK is going to help us find half of the side length. So we can say that would be our opposite side. Y'all recall? So the sine of 20 equals MK over 5. And if we need to rewrite, so TOA, we can do that. Remember, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So when we go and solve that, we would have 5 times the sine of 20, which I got to be approximately, so MK is approximately 1.710. Alright, so we've found half of our side length. Now we need to find our apothem. And our apothem is our adjacent, so we're going to use our cosine. So the cosine of 20 equals LM over 5. So we can say 5 times the cosine of 20. So our apothem would approximately be 4.698. Alright, so those are just 2 easy steps where you can go ahead and solve for the side and the apothem, because in our equation, remember, you need 1/2 the apothem times the perimeter. So we're on our way to doing that. Next, the regular nonagon has two side lengths, or has side lengths of S, and so we know that JK is our side length, and we found MK, so we're just going to take 2 times MK, which we found to be approximately 1.710. So we come up with our side length to being about, let's see, let's do it on our calculator, 3.4202. Alright, and then we also again have our apothem to be 4.698. So those are the two things that we really have to find before we start at our area. So after you find your apothem and your side length, you can go ahead and find your perimeter, because we know that we have 9 sides and each side is 3.4202. So we can say our perimeter is approximately 30.8 units. So again, we're just kind of moving those things down to get the next step to our area equals 1/2 our apothem, which we said was 4.698, times our perimeter, and we would get approximately 72.3 square units. So if you need to go back and review that problem, that might be a good idea, just because there are a lot of steps, but once you get in the hang of what you need to do next, then it will feel like it is coming to you a lot easier. So last thing, use the steps from our page 2 again, and I want you to try to do number 3. I have tried to separate my steps like we do when we are talking about our steps, so hopefully that will help just a little bit. And again, if you ever have any questions, please feel free to ask. This is a little bit more complex lesson, but I think once we get the hang of it, we will actually be pretty comfortable with finding the area of regular polygons. So again, if you need to go back and re-watch the first video of 11.6, or you can restart this one as well to look at example number 3. That might be a great idea. And then last but not least, just finding the lengths of regular n-gons. We'll go over that more, but this is something that could be helpful, so just read over that. To find the area of regular n-gons with radius r, you may need to first find the apothem A or the side length. So this is going to give you a little bit of a hint as to if you have, what do I do first. You can look over that, and then the steps will also be helpful as well. So hope you enjoyed, hope you are learning still, and putting forth the effort as well. So have a great night.